Hello, all. As you start to join us in our meeting room, waiting for a few people to get in, get connected to audio. Super excited for this month's meeting on generative design in use. I don't know whether you guys feel the same way, but to me, generative design always seems like it's that really awesome thing that I just can't do. There's like all of these floating pieces and parts, and I don't even know where to get started. But we have two really awesome presenters, Sofia and Erik. You guys might, well, I should say three. We have two presentations. We have Sofia and Erik from last year. You may remember them from last year's generative design, actually exactly a year ago, maybe not to the day, but they also presented at AU last year and gave us a recap on that. You guys might remember that. They are over in across the pond, so we appreciate them sharing their time with us today. We also have Sean Fruin. Maybe
Hi.
You may know Sean. He is an MEP specialist. Really wonderful to have him part of our group today. And so all of you guys with MEP or have an MEP background have some representation today. That's one thing that we've been getting in our polls. With that being said, you can see I'm sharing my mural page. I'm gonna go ahead and share the link in the mural for those of you who just got in here. Make sure you join us in the mural. It's an interactive landing page for you as the participants to be able to play, give us information, share information, get information. You can see everything on the left here in gray is information about the group. One really wonderful thing about Mural is that all of these things mostly are clickable links, right? You want to take the survey, click on the image, double click, that is. You want to go join our BIMXT group within LinkedIn, which I definitely recommend that you do. Double click on the LinkedIn group image. You can also see that we're run by a board of advisors. Very grateful for this group to advise future meetings and happenings within the group. Also, feel free to double click on any of the Twitter, LinkedIn, etc. images next to those names, and you can connect with those individuals. Below that, you can see the individuals presenting today. 3 presenters for 2 presentations. Once again, Sofia and Erik have their LinkedIn information there, as well as the link to the video of their last year's presentation for BIMXT on generative design. Super excited to get the update from them today, as well as Sean Fruin. You can get his Twitter and LinkedIn information there.
Yeah.
One great thing about Mural also is that you can zoom in and out as far as you can, so you can get really close. Now, everything over here on the right in blue is for you guys. I want you guys to interact in here. If you have a question for us, you want to let us know where you're calling from. We actually have a winner from last month, because we're going to pick a winner every month for a participant within the Mural board. So last month's winner, Joseph Kirkpatrick, thank you so much for participating in the mural. And of course, with BIMXT, someone at CAD Micro will reach out to you to give you a $25 Amazon gift card. Who couldn't use that? I could use that right now. Please include your name on where you're calling from today. Next month, you might be the one that wins the $25 gift card. So please let us know at least where you're calling from today for that opportunity to win. You can also see over on the left there, you can tell us some people are already doing so, right? Looks like Christopher Alexander is playing with Dynamo. Love that multitasking. Yoshi's my fave, right? So please let us know how you're doing today. Maybe you're hangry. Between breakfast and lunch for me, I'm getting pretty hungry. I need some more coffee. And if you have any ideas for future topics, one thing I recommend that you do, you can see here that we essentially have broken it up by discipline. So if you come down here, you can see I'm more related to the BIM-IT group. That's usually where I relate myself. So I would actually take the one related to BIM-IT, has the little computer on it, and just copy that note. You can right click and you can duplicate it, move it around, and then tell me, how you're feeling today. I'm here to network, right? I'm going to just come in here and I'm going to say, Dana's here to network. Maybe tell everybody that I'm coming from Virginia, right? So please make sure that you're interacting with our mural. Later on today, unfortunately, my GIF isn't working in the tip of the week. So I guess I'll just have to open it up and show it to you guys on interacting with schedules and some nice, cool things that we can do there. Let me know if you guys are seeing the GIF. The GIF was working. I want to put it on there. Well, without further ado, I'm going to stop sharing and I'm going to push it over to Sofia and Erik. How's it going, you guys?
Thank you so much, and thank you for that awesome introduction, Dana. Yeah, we're calling from Denmark actually today, from Copenhagen.
Super exciting. You guys are typically in Sweden. I think that's where you were last year.
Yeah, actually, so we're based in Sweden. We're calling from Denmark today. So can you all see my screen?
Awesome. Coming through right now. Looks like it's starting to share.
Usually takes a couple. Okay, first of all, thank you so much for having us today. We're super excited to be able to be here and to be able to present how we work with generative design at Parametric Solutions and how we use it in practice. So first of all, my name is Erik Forsberg, and I'm one of the co-founders and the CTO of Parametric Solutions. And I have a background in civil engineering, and I'm also a data scientist. And with me here today, I have Sofia.
Yes, so my name is Sofia Malmsten, and I am the other co-founder of Parametric Solutions. And I have a background as an architect, but I've also been working a lot with computational design and parametric design. So we together decided to start Parametric Solutions and focus on generative and parametric design.
And we also have Frank Hendrik, which is our tech lead. That's part of our team, but he's unfortunately not been able to be here today. He's a full stack developer, and we are an AR specialist. And I forgot to say that in the beginning, that if you have any questions or thoughts, or you can either raise your hand in the chat, or you can just stop me and we can talk about it, or write it down and we can have a Q&A at the end of the presentation. It's either way you like it. So, like we mentioned, we both have a background in architecture and civil engineering. So when we think about generative design, what usually comes to mind is like maybe these optimized shapes where you find the structural optimization and try to find the best possible way to use the material for minimal material usage. But when we think about generative design as architects and engineers, we think about the built environment and how we can use these kind of algorithms or these kind of tools in practice to enhance the living quality and the way that people use and interact with the buildings. And with a background in architecture, we know that architecture can be amazing, and that it's so much fun to, like when you jump into a new project and you have all these like different visions of what it could be, and you have so many ideas that you want to try out. But the reality is that that's part of the story, but there are also a lot of different parameters, a lot of different aspects that you need to solve or take into consideration. And most of the time, from my experience, at least in the early stages of the project, there can be a lot of unknowns. Like you don't know if you will actually fulfill the vertical sky component or daylight requirements, for example. Will you be able to get enough parkings in the project, for example? And this list of parameters just goes on and on. So it's not enough just to be an architect. You almost need to be an expert in all these different fields at the same time. And it's really hard for the human brain to be able to see and compare so many different parameters at the same time. So when we think about architecture and early stage planning, we think about complexity. So many different things that you need to consider, right? And I mean, of course, all of this complexity, it takes a long time to solve it. And it's really resource demanding as well. And sometimes it can also lead to that you maybe go into the wrong path in the beginning of the project. So you actually end up doing something that you need to go back and redo it later, go down a different path later on. So what we want to do is to be able to go back in time without losing time. So we write algorithms and design logics to create a lot of different building proposals in the early design stages for urban projects. And we evaluate all the different alternatives based on different parameters. And this is a schematic sketch of our idea of what a generative design process can look like. So you start with the algorithm, that is the definition of the design logic, and the rules and constraints for what you can build. And then when you run this algorithm, it can create different kinds of design proposals based on the same set of rules and regulations that you have in the algorithm in the beginning. And this is all a little bit abstract right now, I understand that, but we'll look at some more concrete examples later. And then we have, for each of these alternatives, we evaluate them based on, it can be client-specific criteria, or it can be project-specific criteria, or it can be general criteria that you always want to evaluate. And based on the design and the data together, we pick one or a few designs that we want to continue working with and do more detailed design of. So, like I mentioned, to make this a little bit more concrete, we want to show you this project that we've just been working with here in Scandinavia, where it's a multi-family house project, as you can see, where we have encoded the specific design logic for how the houses are being placed and the distribution of the living units, for example. And they're all based on the same algorithm, the same design logic at its core. But as you can see, you can still end up with vastly different design proposals just by tweaking some of the numbers in the beginning. And
what a gorgeous visualization at that.
We're like, we should throw this in and show it. And this one also looks nice. So this is with the vertical sky component turned on. And what we wanted to show here is that you can also, for the alternatives, you can run simulations in parallel, and you can evaluate the proposals not only based on like single numbers, but also like as a visualization like this, like a distribution of values, for example. So this is all good, but actually what you mentioned in the beginning, Dana, with like you have all these like schemes of how you work with generative design, and you heard a word and you think it sounds really interesting, but the reality is that it's actually it's quite hard to work with generative design, especially if you like create your own design logic. So what we have noticed is what happens most of the time is that But
there's a button in Revit now, right? Yeah. Can I just hit generative design and do? That's what I want it to be. I want it to be that easy.
Yes,
yeah, exactly.
This is what we're coming to, right?
That's what we want to create, right? But the thing is that button, should that button be the same for every company or every person, or should it be a slightly different button for every person? And I think that's where the problem is, that you have this amazing script that you created for a specific project, but then when you want to run it for the next project, you need to tweak it a little bit. And I actually have this picture as well. I really love Rhino and Grasshopper. We all do at Parametric Solutions, but we also see the problem with that. You create design logic.
Have you sent this to McNeil? You guys have to send this image to McNeil.
We actually had a webinar with them earlier this year where we used it as well, and they had a good laugh. So
wonderful.
No, so what I wanted to say is that you have this design logic and you have to tweak it a little bit for every project. And what happens is that you spend maybe 20 hours to create the logic or the script or whatever you want to call it, and then you spend 80 hours to run it for certain projects, for just making small tweak, and the logic just grows and becomes more and more complex. So what we want to do,
that's pretty common, right, with the early design process. I mean, it's not necessarily that you can just rinse and repeat necessarily, right? I mean, there is a lot of kind of finesse in terms of what are those limitations or the actual algorithms that you want to set. What are the limitations that you're setting? What are the adjacencies? Do the adjacencies matter? Does the property line matter? Does building height matter? Right? All of these, the program, all of these different things that really, really make it hard to make it a one button click.
Yes, exactly.
That is the thing.
That's the problem, right?
Building code.
Building code.
Building code, yeah,
that's
exactly.
a huge issue in the US with us, for sure.
Yeah.
So we think that the answer is somewhere in between. It shouldn't be button, but it definitely shouldn't be this either, because this is disencouraging. When you see this spaghetti mess, it's so hard to actually just pick it up and start using it. So we want to lower the bar of using generative design by making it more accessible to people, but at the same time keep the complexity in there and the actual power of generative design. So keeping the power of generative design would make it more easy to use and more accessible. That's our goal. And we do this by connecting a lot of different microservices. So we have all these things that you see on the screen right now. We have created a platform where we connect all these small bits and pieces to be able to give the user a user-friendly and easy-to-use interface for running generative design Grasshopper scripts. And this is the way we usually think about it. We have like four parts of the process where you define your specific constraints. It can be the adjacency, like you mentioned, for example, of the buildings, or it could be the height of the floors of the building, or it could be any kind of parameter that you want to define. And that's being sent to a server where all the heavy calculations are being executed. And then all the data is being saved in a database, and you can interact with it through the platform again. And now I think Sofia is actually going to show you a little bit of a
live demo.
A teaser, yes. What it can look like.
Actually, it is very similar to generative design inside Revit. The difference is this is outside Revit, but it's basically the same principles as generative design inside Revit. But what we've realized is that sometimes people in the earliest stages, they don't even work in Revit at that point, like property developers and like market departments. And there's a lot of disciplines that are not BIM experts and they're not working in Revit. So therefore we're publishing it in a web browser, but the principles are exactly the same.
I think it's still important into Revit.
Yeah, definitely. But it's like different purposes. And yeah, but so as we've done, as Erik showed, we have all of these microservices that we've connected in the platform. But as a user, they only need to take care of these 3 steps, which is basically initiate, then the machine will iterate, and then we evaluate the concepts. So let's see. I will.
There you go.
Yeah. So the first step, which is the initiate step, we've created the platform and we have set up a sequence of setup criteria. So we have the input form here, and we can just do test. And then we have actually connected it to Mapbox so that we always have geographical information. So you can type in a location here, or you can just zoom in and draw. So it's generative design for site planning. So here you can draw the outline of a site. It's quite slow now. Yeah, I think so. You draw the outline of a site like that. And here we have published predefined scripts. And as you said before, Dana, like there is not only one size fits all or one script fits all. So if you're doing like residential development in the suburban areas, that it's one logic. But if you do an infill project, you need to specify adjacent buildings. You have another like definition or other requirements and regulations to take into consideration. And if you do single family projects, that's something totally different. So what we do is that in this platform, it's more like a hub and a toolbox where we publish scripts with different logics. And then you can select what kind of script suits me the best for this specific project. So the thing is, you can also add custom scripts if you have a very, very specific demand. Like, okay, I'm working with these modules, these dimensions. That logic can be part of this as well. So it's not as generic as the other platforms. But if we go to this one, for example, depending on what study you would like to run, you have a different setup of criteria. So you select what type of buildings you want. something like this, and you specify dimensions and stories. And down here, you can specify street width and recreational area per person, parking, a lot of different aspects. And
very sleek interface as well, right? I mean, I think that's one thing that I think you guys paid a lot of attention to, is making it very user friendly.
Exactly. Yeah, we want it to be as simple as possible, even though it's really, really complex in the background, but we want the appearance to be very, very simple.
Yeah, it's enough complexity anyway, so you don't need to add extra complexity in the interface.
Exactly. And then we have this kind of modular approach. So for the generation part, you select what kind of things you'd like to generate, but then you can also add different simulations. So what is actually happening here is that we execute scripts in a sequence. So instead of ending up with like hundreds of Grasshopper files or Dynamo files, it's like a customized version in the web for both generative design, but also a little bit like Dynamo Player, where you can actually say, okay, first I want to generate this building on this site, and I want to run a vertical sky component simulation. Then I want to add sun hours, and I want to do a view simulation. So you add you can combine it with your own workflow, basically. And then you go next, you select how big your study should be, and you press create. And this one is then sent to a server, and the server will start drawing the alternatives for you.
Yeah, right.
Like this. And then this will take approximately 5 to 10 minutes or something like that, depending on how large the site is and how many options you want. But what you get when the study is done is, I can just show you. Yeah, you see this one is pending, so it's creating right now. But then you have access to the interface where you can, there's something with the connection here, but then you have access to the options, very similar to the other generative design tools you've probably seen, like generative design inside Revit. So you have your thumbnails here. You have the parallel axis diagram, and when you click on it, you will get the 3D model directly.
Oh, it's nice.
It's night, so I will change the sun studies. And then you get a lot of like data correlated to each and every alternative. You will get the 3D models. And the same way as generative design inside Revit, you have the possibilities to apply filters on the different criteria or aspects, and the list up here will then change according to what kind of filters you've set up.
I see. So that the alterations that you select in the beginning isn't necessarily fixed. It's still dynamic based off of how you're interacting with the algorithm once you actually get in here.
Exactly.
Yeah.
Exactly.
Awesome.
So it's like generic in one way, and we try to make it as simple as possible in terms of how to interact with the platform and so on. But what is actually going on in the background is that we are putting a lot of Grasshopper scripts on a server, and we've built a wrapper around it in order to scale up the usability of generative design, so that people that actually maybe people that are not working in Revit could also use the benefits of doing this. So it's like a mix between like SpaceMaker, generative design inside Revit, Dynamo Player in the browser.
So you said the reason why we use these filters is that when you set up the script, like you predefine your parameters in the beginning, you don't want to have a too narrow scope, because generative design is all about exploration. You want to get as many designs as possible, so you can explore every single corner of the design scope. So you want to explore a broad scope, and then you want to be able to zoom in on a specific, it's almost like a mirror board. You want to be able to zoom out and zoom in, right?
Exactly. Yeah, so basically just to sum up what this is about, you can think of it a little bit as a cassette player, where the Grasshopper scripts are the tapes, and the platform that we're building is basically the player. So it's based on Rhino Compute, and we have the possibility to add these Grasshopper cassettes, and then you can decide your own workflow, like what you want to play first and in which order, and what kind of recipes or scripts do you want to use. And we are constantly adding layers and evaluations to the platform. So we have the generation part for multifamily housing and for volumetric studies and for site planning. And then we're adding these layers like vertical sky component, walkability, topographical conditions. And we're like constantly adding layers and layers so that you can evaluate and generate more with generative design. And it would be great to hear your thoughts and have a discussion about it. We're always like open for collaboration and talk to people with knowledge in the industry. So any thoughts?
Well, it looks like based off some of the comments, it looks like most people are speechless. I'm not getting anything in the I mean, it looks like Dan and Andrew literally are awestruck, Dan just said. And I don't have any comments in the mural. Please feel free to go in there, you guys, within the chat, either chat or in the mural, and add some things there. So thank you so much. We can find you guys at this website and send you guys an email if we're interested. That was really, really impressive. It really does look like you've incredibly simplified the process.
Yeah, we hope
so. That's what we want to do.
That's our goal.
That is fantastic. Well, once again, before we jump over to Sean, I'm going to share my screen again and just remind you guys how we can interface within Mural. Now, up here within this top left group participant area, I've locked all these. These are for reference. You can see for reference only. Down below, you can see maybe you align with architecture, right? You can take the architecture, right? There's a little house so that you know which one aligns to you, right? In any one of the ones down below, and you can right click and you can duplicate it and move that around and start to maybe ask a question for Sofia, right? How did you possibly create that application, right? Whatever you want to ask, and maybe put your name if you'd like. You can be anonymous if you would also like, but we definitely want, oh goodness, look at me moving stuff. We definitely would like your name next to your location. So if nothing else, please make sure you're coming in here, adding where you're calling from. If nothing else, just adding a note. You can add just a note in here. Let us know your name, where you're calling from, and maybe you'll win a gift card next month. So any questions that you have for Sofia, Erik, for Sean as he's doing his presentations. Notice we also have some polls along the bottom. So does your firm use generative design? What is the most exciting aspect of generative design in your opinion, right? Maybe you have some info to share or a question. Please throw it up there. So I will stop sharing and move over to Sean. I'm super excited to see what you have for us today, Sean. Always super excited to see what you're working on. Of course, we chat quite a bit, all right?
I'm excited just because there's a lot of parallels and see how all this comes together, hopefully, with MEP involved. So I was going to go over generative design for MEP. And I really just wanted to kind of think about it as like, what problems, like how do you define generative design? What problems make it a generative design? So we're going to kind of walk through some examples and build up to like the grand finale, which is, I guess, the true generative design. Right, and all this kind of comes around. So the whole why and everything is really like I've had this vision that someday I just have an architect model in front of me, and then quickly change between HVAC systems and electrical systems and stuff, and just like that, watch that in real time. And rather than people working at their desk, we're all gathered around a table. Maybe it's a hologram with this metaverse talk. And that's just kind of the dream. So how do we get there? We kind of have to start building algorithms and everything, right, to get there. But I think the time's finally here, at least on the technology side. This is a really good, optimistic book about technology and what humans are going to be able to do with it. And here's a good inspirational quote from it, kind of round this, right? So we're starting to get all these tools out there that's letting us build stuff in small teams like never before. And I think we're seeing that in the AEC space. So then, okay, we have these tools, but first, like, what is an engineering problem, right? And so if you open up like a textbook, you find pump equations, right, where you need to get stuff like the diameter, elevation changes, fluid properties, so all these different things, right? And that all needs to be embedded. Another situation is you might have manufacturing and stuff, right? So diffusers have a certain throw with them. There's a certain pattern to go with it. And then of course, like we said earlier, building code, right? That's kind of what goes into an engineering problem. And so it's really interesting, right? Is you can take the BIM model with all Dynamo and other tools and the API and pull all this geometry out to feed all these equations, or to do if statements with the building inspection. And kind of this evolution, right? So we started with doing it by hand, and we're like, hey, the computer, that's really cool. And we're still clicking and doing it by hand, but with a mouse. And then we got to like 3D and BIM. And we're like, this is cool, but it's another dimension, so it takes more time. But now the next really steps, what we're seeing is this idea of generative design, these algorithmic designs, and even especially the ones that feed back on themselves for like optimization. And that's, I guess, what the really exciting stuff is. And to me, it looks like this like pyramid, right? You can't get to the top. So like where we're going, this multivariable optimization without going kind of through all these steps. So it's standardized data, right? Super important. Have to start taking those problems, that knowledge, those engineering equations, and build parametric relationships with everything, right? And then you can get to like optioneering, and then we kind of saw this with Project Fractal. Who remembers Project Fractal, right? It was able just to like check all of A with all of B, mix them all up, and make a whole bunch of options, right? And then we kind of get to one variable, single variable optimization, which is a lot of cool stuff there with genetic algorithms, just being able to find maximums and minimums. Then, right, this all kind of comes together to these multivariable optimization problems, which are just so common to architects, engineers, structural, you know, everything with, we have all these contradicting constraints. So yeah, I just wanted to kind of build this up then. So the first thing is like, right, how important and powerful I want to show standardized of data is. So from the MEP side, if you take a well-standardized architect model that has all of its view scope boxes, you know, its levels, right, stuff like that, you have some standard view templates for, you know, your different phases, different construction types, coordination. If you have a view template for all that, then you can just combine the architecture model and the view templates with Dynamo and something, use all that to create all your hundreds of sheets, right? Big buildings get really, really big, a lot of sheets. So I always suggest to start off with, so what does this look like in practice, right? So I ran through a training manual once with all the things, and this is everything that's on it. Phases do give a little bit of an issue because of the API, but you can pretty much do all these beginning project setup stuff and make sure it's standardized, quick, done. So it's pretty crazy. And I asked, like, is this generative design? It's a very linear process, but is it generative design? So now let's go to another one, the power of like embedding data into our BIM objects, right? So this workflow is super simple where we're just taking annotation, right? We embed some information. In this case, it's about putting electrical receptacles just in the center of the room. It could be data devices. It could be like in a hospital's med gas, just whatever it needs, and make sure that those things get in the room. So rather than having to click and drag or copy and maybe messing up on the way because you're doing hundreds of them, right? You could just put one annotation in there because you know the room's a patient room, and get points at the annotation point and plop those guys in there. And then the designer takes over, right? And actually puts them in the locations, because a lot of times, right, spaces aren't rectangle, even though we tend to think they are. So there can be some tricky ones. So maybe there's some human. Yeah, so the next idea then, okay, so now we kind of see how we can take data, it's standardized, if it's packaged, we can use it. So then what happens when you start to look at geometry from the architecture model? So here we have where we can take a polygon around the space, and you can see the red lines in there is where like a receptacle couldn't go, and the green lines are ones that could go, and you could change the elevation on that. Then once there, you can follow these simple rules. These were written up from a client of mine. Again, just turning that design logic. This is still kind of English, but the next step, taking it further, and then you can see the output on the other side, where we have the distribution of the electrical. So bringing those two ideas together, right, you can start to build these workflows. Maybe you can do it on the mass model where we start to, someone place these annotations, we grabbed them, and then we can combine those things to place hundreds of receptacles in one go. So again, it's not just about necessarily the automation, it's about knowing that this stuff's in the model now, giving it some metadata because we know more about it because it's being placed automatically. And then the designer can come in and start to place stuff by hand. So another interesting problem is this is with lights, right? This is fire sprinklers, really anything that goes in the ceiling, right? So how do we distribute stuff amongst the ceiling? So again, like spaces typically aren't rectangles. There's a lot of like weird situations that you have to consider that you guarantee you wouldn't think about until you like get into the weeds of the problem, right? So then you have to think about, okay, what's all like the geometry I can get from a space, right? I can get its surface, I have its outer polygon, I can get the minimum rectangle to get an orientation of it. I can get an offset to get kind of an orientation of everything. And of course I have that angle, right? We can also have attributes, like this is a bathroom. What's the square area of this space, right? How many doors are there? How many toilet fixtures are there? What's the CFM, right? So all this data comes together in kind of a decision tree. And so the last side is all the outputs. So you see like a corridor space on the top left, right? We have a grid space on the top right. 3 different situations that happen with like the center space, where just one's put in the center and one's put by the closest door. Then what do you do if there's not a door? Exhaust ones, no exhaust, 2 exhaust, small rooms. And then my favorite, bathrooms, get the toilets, put it right over the toilet. I got written up on that once in design, so. Right, so then let's keep going with this idea. So now we can see how we put geometry. Another thing we can do now is start to look at layouts, right? So here we're just taking the main duct, and we have a whole bunch of diffusers, and we're just kind of building a network between those. And then let's say we wanted to minimize this, right? So we could use Project Refinery, or not Project Refinery, Generative Design and Revit and Dynamo, to even do a single optimization on it to actually like minimize that length rather than just flipping through all the things at once. Right, another type of problem, so let's go back and revisit the diffuser problem. So maybe in a large space, right, we have that performance data, the geometry of the space, and we can set the divisions. And with that, we can make a the certain throw with the particular space CFM. And then you can put all this stuff together to kind of come with a clever fitness function that can be minimized. So we're going to take you can put just numbers. So maybe we take the intersection of those things, that's negative. So that's going to minimize our overall score. And so you can kind of build creative fitness functions. So now I want to take all those ideas, and this is the last kind of cool thing I worked on, and going back to the building configurator stuff. This workflow was built for iBuilt, and we were really curious about HVAC, and there's quite a bit that goes into it, and it was a developer. So we were really focused on cost, firstly. Obviously, there's other things you have to worry about, but it becomes a really interesting problem when you think about all the configurations, the different sizes of the buildings, and all the different options you have in equipment to be able to select from for cooling bedrooms, cooling the main living room.
Well, and that's actually a really interesting point, right? It's like the algorithm completely changes when you're designing for a developer rather than like the resident itself, right? Like, how do we define those set of questions based off of like, oh, well, I need that extra parking spot and that extra unit are way more important than, you know, the adjacency, right? And like those types of things, like the, you know, and I guess that's where you really get into the customization further down the line of saying, you know, okay, we put in all of these variables, but now we need to bump this one up where maybe in the last project it was super important, not so this project, right?
Yeah. Well, think about this. So think about, okay, we want to go like, we have a building, we want to go DX, right? Rooftop system. And we want to put all of them for every unit on the roof, right? But then now we're using copper and it's modular construction, right? So now every time we cross a module, we need some type of coupling, right? So now you have coupling options. Do I go with the braze? Do I go with the quick connect? Do I go with whatever? Well, the quick connect is really, really expensive. So the whole idea here is to show like what happens if I switch even the fitting setting to brazed. What does that do to my labor, right, at the factory? What does that do with my labor on the field, right? What happens if I do brazing inside the units, but every time I have to cross a module, I go for a quick connect, right? So you can start to check all these different options.
Right? I mean,
it really is like
built into this. Dan put in the comments, this is really funny. I feel like this guy is playing 4D chess while the rest of us are playing checkers. It's true, because a lot of the automation tasks that we do, right? I know, you guys know, I love Dynamo Player. I like making things Dynamo Player friendly, and everybody can use it regardless of your project and all that. But there's only, you can really only touch surface level things in that scenario, right? Whereas I feel like there's so much muscle built into these types of variables, right? Where it's not just something where you can like, oh yeah, I'm just going to switch this input over and make, you know, turn this slider on and run it, right? There's so much more.
Think about and what it takes. And I should say, like, this was really hard to do. And I don't know if I want to risk coming out because I actually was running it earlier and the Excel file popped up. And so we have a whole bunch of data, all of our procurement data in Excel. And like some of it, I had to get the times on brazing versus all the different ways you connect pipe. I found a YouTube video with a guy like comparing the times. One was like 2.5 minutes. One, the quick connect was like 10 seconds, right? And so like we had to collect that data though to be able to like calculate the labor all the way through. So yeah, I want to try to run through the multivariable one, this example. Hopefully you can see it. I know it's small. It's a lot.
Well, and I mean, I guess a lot of the time we also just think about the actual design, right? And the really early side of things, we're laying things out, we're figuring out, you know, how everything fits inside of the property line, etc. Yeah. But putting that cost layer on top of it, it opens up a whole new door of opportunities, right?
Right. Well, not even doing that. So putting cost while looking at, where is it? Yeah. So in the next slide here, we'll jump to this one real quick. Right. So now we can start to play with these different pipes. And this is just one system up there. If I were to turn them all on, it would look overwhelming, right? But you can just see tweaking certain things, you get certain layouts. And maybe tweaking those, you can't really see it there, but it's actually like deciding that we're going to use PEX piping over copper piping because we used a water system. Or maybe the tweak in there is at each node because we're building, right? It's kind of on graph theory. So each node, the fitting type for a T is quick connect rather than braze. Like you don't necessarily see it there, but what you get out is you get all these, so you can start evaluating equipment cost, labor cost, fitting cost, pipe duct cost, right? You can look at how much unit is, we're worried about area, right? So now we can start to sum up how much space does the system take a unit? How big are the shafts have to be with how this configuration, right? Like a bigger shaft, smaller. How big is my plant size? So we have everything measured on area, and then we have labor, right? So obviously we want to minimize labor. We don't want to have a big bottleneck. So looking at the different aspects that create labor is another one. So then the key point that I didn't get until actually talking to Lily, like while I was even working on this, who's the product manager of generative design stuff, is this idea of the Pareto front, right? And it's this idea of like you're making a really bad decision unless you pick solutions that are on this line. So I might have energy efficiency on the y-axis, and I might have cost on the x-axis, right? So my cheapest would be the lower right one. My most energy efficient one would be the top left one. But if I pick any of these red ones, then it's really a stupid decision. Like it's not an optimal solution. So now what we do is we narrow down all these solutions, right? Like tons and tons of solutions down to a fraction of them, because we can throw out all those red ones. And we can throw it out because I gain something, it might be flipped, but like I improve in one area, but I don't improve in the other. Does that make sense? So I use the Mario Kart analogy, where like, right, it's always this trade-off, and like there's actually a combination of like good decisions. So that's really the biggest thing that you get when you get these multivariables. So again, let's sum up. So data is the kind of key, right? Data is the key. Then we get into like building these parametric flexible systems. Then we get into like ways of optimizing the single variables. Then when it comes to multiple optimization, it's not a question of the right solution. It's a question of the best solution, because there's many solutions. And you can use the tools, right, that are in Generative Design Revit to like simplify and clarify and look at different trade-offs. So what I see too, bringing this all together, is like, I really hope for today that the building configurator, right? So we have building code, procurement data, building configurator, MEP, fabrication, feedback loop, back to building configurator. Like that's the ideal, that's I guess the holy grail to look at. And then of course you have it for different building types and everything too. So the customization that was mentioned earlier. So to end, hopefully it's some inspiration, another quote from Abundance. Maybe we're feeling a little constrained lately, so maybe this will be a good thing with climate change and all that funness. So I'll hopefully leave that for some inspiration to start looking into these new ways of working, take some risk, stop wasting time. And yeah, there's 3 hours worth of AU classes going into way more detail than these examples than I did on these. So thanks, guys.
Thank you for sharing this. I'll make sure that we share those on the mural as well.
Yeah, I'll get them on there. I couldn't multitask like that.
No, I can absolutely do that. Thank you so much. That was so incredibly interesting. Just all of those parts and pieces, just bringing them all together and thinking about how they all interact and layering it all together, just like Sofia and Erik, right? I mean, thinking about how all of these different layers and all the different parts of the program, how they interact.
Again, bringing those two together, architecture, engineering, and I mean,
right on board.
And fabrication and manufacturing. And so
Dan's asking, does it lower the arch ceilings automatically to make room for the pipes?
So there was a limit. So that was one of the things that we wanted to minimize was, and we looked at, so we looked at horizontal. So we had this thing called the MEP hole that was like between the structural. So the question was, do we need one MEP hole or two MEP holes? And obviously 2 is more expensive, and we wanted to keep it 1. So that was one of the things that we were trying to minimize, was like, oh, it might be a good air system, but what does that do trying to put air? And yeah, we were looking at high velocity systems, and it was too much to like keep track of, which is why digitizing it and putting that knowledge into like a framework really helps too.
Zach is asking, is constructability review part of that feedback loop? And later he said with insulation.
The feedback loop. So the feedback loop, whole idea of all of it together is like what I think a lot of people are working on and like what excites me. But so not there, quite there yet. And one of the things, by the way, that's missing on the HVAC thing is there's no look at like how much does the shaft cost, right? And that's a huge factor, right? Especially, and there's no fireproofing in there actually. So if you have ducts, right, you need fire dampers at certain things, and that's not included in it. So even more design knowledge would need to be added.
Well, it looks like there's 2 questions on here for Sofia and Erik in particular about the program itself. How does it license first off, and how does it compare with TestFit?
Ooh.
All right. So
all those little micro programs that are coming together, that to me in my mind is the quandary. It's the intellectual property behind bringing all of that together. Right.
Like that's what's going to take. So it's awesome.
No, so basically what we are doing right now is that we work in quite close collaboration with larger companies like property developers and architect firms. So then we have like special contracts for these clients, but we are planning to release a more generic version, so that more like a no-touch solution, but we haven't really released that one yet. So right now we're focusing on like partnerships and collaborations with clients where we do customization, and we are going to release a more generic version later on.
So it's like an enterprise solution right now. I mean, you can still sign up for it right now, and it's in beta stage right now, the more generic solution. So if you're interested in seeing what it looks like, please go ahead and write to us.
And we're also like constantly looking for feedback. So we have like, you can try it out for a test period and see what can improve and how can we make it better, basically. So
it's a work in progress.
And we're happy to share it and to get feedback from you guys.
I also just need to say, I really like the graph you had on your presentation, Sean, with the dots and the line. It really opened up my...
Yeah, it was great.
Yeah.
Really interesting.
Sorry, it totally opened up mine too. Like it wasn't on my radar until literally 4 months ago. Because I was like, because you always hear, there's this article that came out that's like the complaint about generative design. It's like, why are we making 10,000 solutions? But it's like, no, you're taking 10,000, then you're supposed to use the tool to narrow that 10,000 down.
Yeah.
So like, and I think Autodesk has kind of missed that point too. Like,
it's not about the numbers, it's about like finding, like exploring the scope.
Right, exploring, like narrowing it down. So
you're just gonna build one solution anyway. So, but it's about finding that one solution.
Out of stubbornness, I kind of figured out the tweaking building equations. You could turn like a multi problem into a single. So I was like, I just want to find the answer. That was my mindset. It's like, no, I just want the answer.
Yeah, that's brilliant.
Yeah.
Thank you.
Just give me one that's the most optimal.
Yeah, just give me the answer. So I hit a button and have MEP done.
Exactly. Awesome. Well, I thank you, all 3 of you, for presenting such amazing information. The meeting of the minds, I feel like, of all of this wonderful information and how everything is coming together. I think that's really the beef behind it, is the tying of all of this data, all of the layers that, maybe we just are typically used to looking at one of those layers, but how we can bring all of those layers together. That's really where that feedback loop.
I question who's going to be able to do it, because like huge companies have data on their side if they were good. Like it's really hard to get the cost, like the manufacturing. Like you can't just call out and be like, what's the size of this chiller? Or what's the price for this size chiller? They don't give you the answer, right? But if you have a whole bunch of past projects and you have all this, with the labor data and stuff, but then on that, it's hard to turn the big companies, it's hard to turn the boat. So is it going to be these little nimble companies that bring it all together? So it'll be interesting.
Erik and Sofia, are you guys seeing that as a big question from your clients or that early in the process and saying, facade types, what is the cost difference that I'm going to see if I go with brick versus aluminum, or, different things like that? Is cost a big issue that early when you're going through those layer simulations?
Sorry, something happened with the connections. I lost the first part of the question, but
just curious about cost. If your clients are really coming to you and curious about the different optimizations and all of that and the cost tied behind it.
So I think the biggest advantage of doing it in this way is that we can write customized scripts for different, or we can, in collaboration with our partners, we can write a specific design logic. So of course you won't be able to go all the way and say that this is the final price tag for the project. What you can do is that you can add certain like price indicators. For example, staircases is a big cost driver when it comes to just know how many staircases will there be. And like, especially if you have your own building system and you know roughly how much, like we use this kind of elevator, we use this kind of staircase. Then if you have those numbers, you can get much closer than you would be if you had just like a generic script. So you can add like certain price indicators, I would say, but you won't be able to go all the way and say that this is the profit or the price of the project.
Exactly. It's interesting because that is, obviously people are asking for that, but the cost is like, it's so big and it consists of so many things. So it's really, really hard. This is
you literally have to know like every screw in every
more or less.
Yeah. Well, especially
wire length in every
with the variabilities
screws on top of the wires.
And then the variabilities.
I was about to say with lumber and everything, it's like, I just bought this in a spreadsheet.
Yeah.
Right.
And MEP is also a big cost driver, so that's also part of it.
I really want to see the like architectural system with MEP flexible system.
Yeah.
In one algorithm.
Your presentation as well. I think that would be.
Once we can merge that together, that would be so cool.
Awesome. Well, thank you again. And thank you all to our participants. I'm going to jump off and give everybody, respect their time, but we will stay on here, for a few minutes if anybody has any last questions. Thank you all so much for participating today and participating in our mural.